Okay, guys, number 4 says, take this radian and change it to a degree. So to change a radian to a degree, we multiply by 180 over pi, so the pi's die. And now you're just simply multiplying 4 times 180 and then dividing by 5. And the answer is 144 degrees. And try it on your calculator. 4 times 180 divided by 5. All right, number 6. This is called a complex fraction. Complex fraction means that there's fractions within the fraction. So what I want to do is I want to get rid of the little denominators within this fraction. So I want to delete the r, the s squared, and the 1. I want to get rid of them. I want to be able to cancel them out. So what I'm going to do is I'm going to multiply by the least common denominator, which would be r and s squared. I have to do an s squared because I got to delete that s squared. When I multiply the numerator by that, I'm distributing it across. So I'm really multiplying this term by rs squared, this term by rs squared. And I have to do whatever I do to a top of a fraction, I have to do to the bottom. So I have to multiply this by rs squared and this by rs squared. Now I will see all my little denominators cancel out. This r cancels the r up there, leaving me an s squared. This s is going to cancel with one of these s's, leaving me an rs. And on the bottom, this entire s squared will cancel this r squared. S squared, sorry. S squared and s squared cancel, leaving me an r cubed. And over here, nothing's going to cancel, so I'm just left with the rs squared. So basically, this is it, but it's not in lowest terms. I'm going to factor a GCF out of the numerator, leaving me s minus r times s. And then on the bottom, I can factor out an r, leaving me an r squared minus s squared. Am I factored completely? No. Look at the bottom, the difference of two perfect squares. That can be factored. So I'll do it underneath. So the r stays there, but now I'm going to do a double bubble, difference of two perfect squares, r times r plus minus s times s. Now I'm ready to cancel. I have opposites. I see an s minus r and an r minus s. The s here is positive, the s here is negative, the r here is negative, the r here is positive. They're complete opposites, so I can cancel them out and put a negative 1 on the top. So my final answer is negative s on the top and r times r plus s. When you're given a complex fraction, chances are when you get rid of the little denominators, you're going to have to reduce it. You're going to have to factor and reduce. Chances are. Okay. Number 8 talks about an oscillation, and they gave you the function. And the function was x equals 3 cos of 8t. And then they tell you about this oscillation and the equilibrium point, and it was all scientific. But the basic idea was, what's the period? So we know the amplitude is 3 and the frequency is 8. So the period is going to be 2 pi over the frequency, which is 2 pi over the frequency of 8. And I just reduced it to pi over 4. And that's it. Number 10 is a word problem. But it tells you about number of customers varies inversely with the average daily temperature. As soon as I read the word varies inversely, I know that the relationship is multiplication. xy equals xy. Varies directly is a proportionate relationship. X divided by y equals x divided by y. A lot of you who got this one wrong probably set it up as a varying directly instead of a varying inversely. So you have to remember, inversely is products and varies directly are proportion, division. So I basically just have to fill in these numbers. And it said that the temperature was 40 degrees, 160 customers, and then it said the temperature went down to 25, and we have to figure out the number of customers. So now you're just going to solve it as a regular, did I do that right? 25x, divide by 25, divide by 25, and what was the answer?
256.
256. Is that right? Uh-oh. 12? Mm-hmm. Number 12 gave you a semicircle, and the measure of the arc was 1.38 centimeters. The central angle we did not know, but we knew the radius. So as soon as you see something about an arc and a radius and an angle, it's going to be soar to the rescue. Now you just have to remember where each number goes. The S stands for the length of the arc, which we were given, 1.38. The angle we did not know. And the radius was 4. So how am I going to solve this? For theta, I'm just going to divide by 4. And the answer is?
3.345.
That's what I said. Now that is a radian. If the problem asked for you to change this to degrees, which it didn't, but if it did, how could you change to degrees? What you would do is, you would take the radian measure, 0.345, and multiply it by 180 over pi, so the pi's die. But where is the pi's dying? It's already multiplied into that decimal. So it is going to die. So in your calculator, you're going to do 0.345 times 180, get that answer, and then divide by pi, which you could do on your calculator to practice. But then you'll get the degree. All right, thanks. We're going to go over number 14. There are 3 basic questions that could be asked when we're talking about domain. They could give you a function that's a fraction. They can give you a function with a radical, with a square root. Or they can give you a function with a radical in a fraction. What you need to do is know these 3 cases of domain. The first being a fraction. This is the one you were given. You were given a function, a fractional function, with a numerator and a denominator. And you were asked to find the domain. The domain is x. So I want to know what x's can I put into this function. If I was making a table and I was plugging x's in, I could put any x I want. But there's a problem. I can't allow this denominator to be a 0. So there are a couple of numbers that would make this denominator a 0. I got to figure out what those numbers are and then delete them from my domain. So if I solve this little equation, setting the denominator equal to 0, I dots, I t, set each factor equal to 0 and solve. And I'm doing this quickly because I know you know how to do this. And these are the 2 x's that cannot go into the function. They're not in the domain. Otherwise, the output would be undefined. So the way you're writing this answer is the domain is x, can be anything, but it cannot be plus or minus 3. And that's how you do domains with fractional functions. This is going to come up again and again. We'll have one with a radical, and we'll have one with a radical in a fraction. Mm-hmm. All right. So for number 16, you're adding radicals. What you're going to do first is simplify them, because you only can add like radicals with like radicals. So right now, these are not like. This is an a cubed, this is an a, this is an ab, this is a b squared. They're not all the same. So I'm going to simplify. Remembering your perfect squares, I'm looking for a perfect square that goes into 48. 16 is 1. 16 times 3 makes 48. I'm looking for perfect exponents. Perfect exponents are even exponents. So a cubed is not even, but I can make it even times an odd, right? A to the second times a to the first is a cubed. And then b squared is already an even function, an even exponent, I mean. So now, my 16 is perfect, my a squared is perfect, and my b squared is perfect, so I'm going to pop them out. The square root of 16 is 4, it goes on the outside. Square root of a squared is a, goes on the outside, and the square root of b squared is b. Left inside, I have a 3a. So that's basically done. Now I got to move on to the other one. I got a 2a on the outside, and inside, I'm going to break down my 27 to 9. 9 times 3. My a can't be done. It's going to be stuck inside there. And my b squared can pop out. Nice and slowly, I take the square root of 9. I get 3. That's going to be multiplied by my 2a on the outside. I take the square root of b squared. That will be a b. So on the outside, I have a 2 times an a times a 3 times a b, which is 6ab. And then left inside is the 3a. That makes me happy, because I'm going to be able to add these two together. And now, last one, I can break down my 12 into 4. 4 times 3. And I'm left with an AB stuck in there. Pop out the square root of 4, and the square root of 4 is 2. 5 times 2 is 10. And inside I'm left with a 3 and an A and a B. And then like rads with like rads get combined together, giving me a 10 AB. Rad 3A minus 10 rad 3AB. I'll do more of the evens and the odds tomorrow. All right, number 24. They tell you that there's an angle in standard position and it passes through the point -4, 2. Newsflash. If they give you a point, plot it. 1, 2, 3, 4, 1, 2. There it is. There's an angle that rotates to that point. We want to find the secant of that angle. Well, I can figure out this triangle. I'm using my reference angle. I drop down the hypotenuse from the terminal side in the x-axis, and I'm looking at this reference angle. I know that I went left 4, and I know I went up 2 to make that. So now I simply have to find the hypotenuse. Why do I need the hypotenuse? Because to figure out secant, I got to do half. So I know the adjacent, but I don't know the hypotenuse. So I do a squared plus b squared equals c squared. That's 16, and 4 is the square root of 20, which should be simplified to 2 rad 5. And then you do...
For number 2, you reduced it?